So our integral calculus. So the main objective of this course is to find integrals is majorly to carry out integration, and then we'll see how to apply the knowledge of integration to solve some real life problems. Prerequisites. Differential calculus. So this is Math 121. Then we have college algebra. So these are the main prerequisites. So it is assumed that you have done these two courses, and by now you are able to differentiate functions, and you know different types of functions also. So we start by defining what we call an antiderivative of a function. And it's simply a set of functions that satisfy a condition, an antiderivative of a function f of x is another function, or is a set of functions capital F of x plus c, such that if I differentiate this set of functions, I get back my function f of x. So note that this is capital F and my function is small f. So for example, I can say a third x squared plus 10 a third x power 3 plus 10 is the antiderivative of x power 2, since if I differentiate a third x power 3 plus 10, what value do I get? Derivative of a third x power 3 plus 10 is which function? X squared. And also note that when I say a third x power 3 minus 5 is an antiderivative of the same x squared. And even if I say a third x power 3 minus 99 is also an antiderivative of the same x squared. So we are saying that from this basic example, and the derivatives of functions are not unique, because you say this is a different function, these are different function, these are different function, but all of them are satisfying this condition. So depending on the value of, regardless of the value of the constant c, when this is the stem of the part involving the x, then we'll end up with the same antiderivative, the same to be the antiderivative of the same function x squared. So we usually write so maybe if I can call this one, let me call this one equation 1. So we usually write equation 1 as this. So where this is the integral sign, so this is the integral sign or integration sign. Then in this form, this function f is called integrand. F is called the integrand. And then all this is called the antiderivative. And then C alone is called constant of integration. And then this dx is just a differential. And x is called variable of integration. So in simple terms, the problem means find a function whose derivative is f of x. So when then this we say integrate f of x with respect to x. So I'm simply asking you, can you provide a function whose derivative is f of x? So for example, in the above cases, the problem will be written as integral of x squared dx. And so all these possibilities we have given here, this and this one here, all of them works. And so when you fix this position to be any constant c, and you maintain a third x power 3, then that will be the structure of the function you need to differentiate. So this is the same as a third x power 3 plus c. So which means that when I differentiate this function, I'll get this x squared. So the process of finding and the derivative of a function when simply and the derivative of a function is called integration. So in simple terms, the process of finding capital F of x plus c when given small f of x is called integration. And so throughout the course, we will be interested in finding antiderivatives of functions. So simply we'll be interested in integrating functions to get their corresponding antiderivatives. So there are two types of integrals. One we call indefinite integrals. And then two definite integrals. So for you, indefinite integrals, they are integrals of this form. While for definite integrals, you'll be given the limits of integration. And if this is the case, then this is how the integral looks like. So in this case, the number A is called lower limit of integration. So this lower limit of integration, this one is called upper limit of integration. And for definite integrals, there is no constant of integration because it cancels out when you replace the limits. But for indefinite integrals, the constant of integration must always be provided. So note, always provide the constant of integration C whenever you are dealing with indefinite integrals. And you should appreciate that even from the precursor example I've given, where different values of the constant doesn't matter for the function x squared. So you must always remember to include the constant of integration when you are dealing with a case of indefinite integral. And that is a case whereby the limits of integration are not provided. Then let's give some basic properties of integrals before we state and discuss a few techniques of carrying out integration. So some basic roles of integrals. For one, the integral of f of x plus g of x is the same as the integral of f of x dx plus the integral of g of x dx. That if you want to define the, remember you now need to put dx here. If you want to define the integral of sum of two functions, it's as good as getting sum of the integrals of the two functions. So integral of sum of two functions is the same as sum of the integrals of the two. Number two, integral, and still this works whether you are dealing with definite or indefinite, still the same rule applies. Integral of f of x minus g of x dx is the integral of f of x dx minus integral of g of x dx. So similarly, just the same way for the case of addition, if you subtract two functions, their integrals is as good as the difference between the integrals of the two functions, both for definite and indefinite integrals. Then number three, integral of a constant times a function f of x is the same as constant integral of f of x dx. So that means that if you multiply a constant by a function, and then a function which depends on x, and you integrate the product, then it's as good as factoring out the constant out of the integration sign, then carry out the integration of that function, then finally multiply by the constant. Still both for definite and number four, d dx of the integral of f of x dx is the same as f of x. So the derivative operator and the integral operator are inverses. So when you differentiate the integral of f of x, you get the same f of x. Integral of minus f of x dx is the same as negative integral of f of x dx. Then number 6, integral from a to b of f of x dx is the same as negative integral from b to a of f of x dx. It tells us that when you are dealing with the definite integral, if you swap the order of limits of integration, then we negate the value. So those are the basic. I remember from 1 up to 5, it applies both for definite and indefinite integrals. And number 6 says that if you interchange the limits of integration, then you negate the value of the integral. Am I too slow?
Right, that is speaking for myself.
Okay, Agnes? Fine. Okay, good. So then now, having given the basic integral properties, let's so techniques. We call them techniques of or methods of integration. So the word technique, same as method. So one, the basic one that you know from your high school is what we call power rule. Power rule says that to integrate x power n, the x is the same as x power n plus 1 divided by n plus 1 plus c. And there's a restriction that n must never be -1 for that to apply. So that's what we call power rule. So for example, if we ask you find the integral of x power 2 dx, then the answer will be x power 2 plus 1 over 2 plus 1, then plus c. And then you'll get x power 3 over 3 plus c. This is what was used in high school. And we still revisit it because there are cases where we deal with polynomial functions where that rule will be very handy. Another example, if you are given integral of, say, 2x power 4 dx, then to carry out this, we'll have 2x raised power 4 plus 1 divided by the new power 4 plus 1, then plus c. And so this will give us 2 over 5 x power 5, then plus c, etc. So the thing is that if you are dealing with functions of the form x power n, to integrate them, provided n is not -1, you simply add 1 to the power, then divide the expression by the new power, and then remember to add constant of integration. Another example we can give is the integral of x squared plus 2x plus 4 dx. So here we'll have x power 2 plus 1, we divide by the new power 2 plus 1, plus 2x. When I don't put a power, it's always 1. So 1 plus 1 over 1 plus 1. And when we don't put an x here, then know that it is x power 0. So we add 1 divided by the new power plus c. So that this will give us x power 3 over 3 plus now 2 and 2 cancels out, so we'll have x squared, and then plus 4x, then plus c. So that's how we apply the power rule of integration. So technique number 2 is what we call substitution method. So the substitution method or technique for integration is just another special way of reapplying chain rule when you are doing the differentiation or the differential calculus. So you fix one part of the integral as u, and then once you have fixed, you convert the integral into this new variable u, and then evaluate the resulting integral. So I will not go into nitty-gritty. Let me list other method then now. What you are going to majorly dwell on today is this second method, substitution method, but I want to list integration techniques first. So number 3 is what we call integration by parts. Then number 4 is what we call integration by partial fractions. So number 5 is trigonometric substitution. Number 6 which we really don't, so this is what we call numerical integration. Here we have what we call trapezoidal rule. Simpson's rule. I have what we call Romberg integration. etc. So there are many other techniques, but we've been tested with this, what we have listed. So the numerical integration part, if time will allow, we'll do it in this course. If time doesn't allow, we'll do it in numerical methods. But what we must do and what we have to know is to understand and apply the integration by power rule, integration by substitution method, integration by parts, integration by partial fractions, and trigonometric So before now, we dwell into the nitty-gritties of each of these methods. Let's also give some standard integrals involving some elementary functions that we are going to majorly interact with along the way. So some basic, let me call elementary integrals. So remember, I've told you that the problem of integration is simply the reverse process of differentiation. So differentiation and integration are inverses of each other, are opposites of each other. So to integrate, you need to understand how to differentiate. And it is always easy that when you write this, means find, if I ask you find or evaluate this, means find a function whose derivative is f of x. That's simply the problem we are trying to answer. The integral of f of x dx means, or the value of the integral of f of x dx means we provide a function whose derivative is that f of x. So for instance, the first one, the integral of e power x dx is which function? I'm asking you, if you remember what you're doing in differential calculus, what function should we differentiate to get e power x? Okay, maybe that's a hard problem. Huh? I understand. Let's forget about my question. Let's do some recall. So very hard. So pause this. Then recall. This was let's go back to Math 121 class and do some activities here. We shall revisit this after this activity. If y is e power x, then dy dx is if I give you a function y equals to e power x, what is dy dx? When you differentiate e power x, what do you get? Agnes?
It's supposed to be.
Okay, good trial. Wrong answer, but good for learning. Valentine, what should we do? Agnes will not escape this. Valentine is safe because I'm not the one who taught him. So when you differentiate e power x, what do you get? Okay. Or you want also to give us a wrong answer, but it's good for learning purpose. So remember, we said in Math 121 that the exponential function, if someone, this joke in mathematics, if someone tells you that you are, we can actually say that people in Kirinyaga County, most men in Kirinyaga County behave like exponential functions. They will not change. They'll still continue to take the illicit brew. Even if they close the bus, at the end of the day, they'll find a way of getting to drink the alcohol that is prohibited. They will never change. So if someone asks you or tells you that you behave like an exponential function, e power x, they simply mean that you don't change. Whatever means or what is done, you still remain the same person. So the function f of x equals to e power x behaves in such a way that when you differentiate it, you get the same function. And also when you integrate it, you will get the same function. So if y equals to e power x, then dy dx is the same thing as e power x. And this is how we are deriving the relationship between the differentiation and integration. So when you write dy dx equals to e power x is the same thing as saying, if I multiply through by dx, I'll have dy is equals to e power x. And then I hope that one makes sense to you. If you see dy dx as a fraction, I just multiply through by dx, okay? Yeah, then you supply the integration sign on both sides. So I supply the integral sign here, and I supply the integral sign here. So remember, the differential operator, D, is the inverse of the integral operator this sign. So whenever you are applying them, D of integral, then this thing is like they are canceling each other. Like asking you, what is 3 times reciprocal of 3? I get 1. What is 4 times reciprocal of 4? Equals to still 1. So whenever you have this integration sign and this D operator, in quotes, is like they are canceling each other. It's like this and this cancels each other to give you 1. So you remain with the function. Please, you don't cross, but I'm just saying that that's really the layman interpretation of that. So this will give us y equals to integral of e x dx. And you see my y was this one here. So I write e power x. And because I'm dealing with the indefinite integral, I'll add a c. Okay? One example is never enough. So if you are not understanding, it's still it is very normal. You may not be make sense. You will not you can fail to understand on the first example. But my main aim here was to explain this, that if I give y equals to e power x, then dy dx is e power x. Number 2, if y is sine x, then what is dy dx? when you differentiate a sine function, you get when you differentiate a sine function, what function do you get? Are you still in class?
It will remain the same.
No. Same is for exponential. So when you differentiate a sine function, you get a cos function. So the derivative of sine x is cos x. Number 3, if y is cos x, then dy dx is minus sine x. So these are the things we did in differential calculus. And number 4, if y is minus sine x, then dy dx will be minus cos x. And if I say if y is minus cos x, having given you the value of dy dx for cos x, what would be the value of dy dx for minus cos x?
Sine x.
Yeah, because now negative and negative cancels out, okay? Yeah, so this will be sine x. Then number 6, if y is tan x, these things are standard, go and check them. Then dy dx is x squared x. Number 7, if y is sec x, then dy dx is sec x tan x. Number 8, if y is cosec x, then dy dx is going to give us negative cosec x cot x. Number 9, if y is cot x, then dy dx is going to be negative cos x squared x. And check more other relationships among the trigonometry. Okay? Today we are not complicating your life. We are just laying the ground. So we will not do a lot of stuff. So after this one, then now I want us now to go back to what we had posed initially. Once we write those standard integrals, we discuss integration. only. And then I'll give you time to go and review your differential calculus work to familiarize yourself with the simple differentiation of functions, because we will require that knowledge as we proceed back. So you can never go far without reviewing your differential calculus work. So then now, let's go back to our toolbox now. So the first one, integration of e power x. I mean, I want you to tell me a function whose derivative is e power x. From that list, the answer will be a function whose derivative remains to be e power x, and you remember to add the constant of integration because this is an indefinite integral. Correct. Number 2, integral of cos x dx. I mean, go to that list and identify the number whose derivative is cosine x. A function. So this is how you respond to my question. This what this means. This line means a function whose derivative is cos x. This is what we are saying here. So let me project here. On this list, which number gives us a function whose derivative is cos x? Remember, derivative, I mean dy dx. Sin x, this is number 2, okay? Yeah, remember, it is very slippery if you are not careful. People confuses it. But I'm saying that whenever you see this sign, when I write this box, f of dx, someone is simply asking you, can you provide a function whose derivative, and when I say derivative, I mean dy dx, is that box. Derivative, a function whose derivative is what is written here, is what you are looking for. Okay? Yeah, so when they write integral of cos x dx means we provide a function whose derivative is cosine of x. And from number 2, you clearly see that dy dx is cos x if your original y was sin x. So, yeah, so the answer becomes sin x. Don't get confused. It's possible to get confused here. Don't confuse the integration of cos x and differentiation of cos x. Integration of cos x is positive sin x, but differentiation of cos x is negative sin x. So, yeah. So number 3, integral of sin x dx. How do a layman understand this? We provide what? Is a function? Yes, we are looking for a function whose dy dx is sin x. So what is the value of that function? What's that function? Correct, negative cos x. So the answer becomes negative cos x. So note that when you integrate a sine function, you get a negative cos x, which is not the case which is not the case when you are differentiating the sign. If you differentiate the sign, you get positive cos x. But when you are integrating it, you get negative cos x. So, good. Number 4. Integral of sec squared x dx. Correct, tan x plus c, because this problem means we are looking for a function whose derivative is sec squared x, and that function is tan x. Then number 5, integral of cosec squared x dx. But negative, remember, because if you go to the line of cot, this is negative cosec squared. So for you now to have the positive, now you have to negate this one first. Okay? Yeah, so negative cot x. Then number 6. By the way, I was to add something here. If we are to call it number 10 to this differentiation list. If number 10, if y is given by ln of x, what is dy dx? One over x, okay? So when the function is ln of x, then dy dx is 1 over x. So when someone asks you, can you find the integral of 1 over x dx? So what will be the value? Ln of x. And when we write ln of x, we usually put with these vertical lines, just to insist that it is only defined when that number is negative. So in most cases, we find 2 vertical lines are placed to sandwich x to simply mean that ln or the logarithm is only defined for non-negative values. So those are the basic or standard integrals that we should actually be at our fingertips, because we'll make use of them. Maybe number 7, if I say integral of sec x tan x dx will be a function whose derivative is sec x tan x. Correct, sec x plus c. So you can extend this list. Just go to your Math 121 book and see how you are getting the derivatives of those standard functions, and then reverse the process. You'll generate your toolbox for integrals. Then now, let's now discuss what is the substitution method. It is a very easy method to apply, because it's simply a special case of if you are to relate to what you are doing in the world of differentiation, is simply a special case of differentiation by chain rule. I hope you remember that if you are given y equals to e power 2x, then someone asks you to find dy dx. What are you supposed to do? If you are given y equals to e raised power 2x, what is dy dx? xe? Which method do you use to differentiate that? So let me remind you. But remember, after this, go and review your work in differential calculus. So here we use what we call the chain rule. So chain rule where you are going to fix this to be u. So we say let u to be e raised power, u to be this power 2x. And so y will be e power u, because we have fixed this power to be just one variable u. And so from u, you'll get du dx, which will be 2. dy du, because now y becomes a function of u, is just e power u. And so dy dx by chain rule is given by dy du times du dx. Okay? Yeah. So then you substitute. So we'll have e power u times 2. So it will be just 2 e power u, and this will be 2 e power 2x. Remember, you don't leave your answer in terms of u. Okay? This is just a recall. We have not started discussing the substitution method. So this just recall from your differential calculus work. And if I give you y equals to sine 2x plus 3, find dy dx. What do you fix to be u? In this case, we fix what to be u? Which? Okay. To be? Yeah, that's what we fixed to be u. Remember, if this thing was sine y equals to sine x, what would be the value of dy du? What would be the value of dy dx? Assuming the whole bracket was just x. Dy dx will be? If I only had an x here, not 2x plus 3. Just check from your toolbox what you have just done. If I had y equals to sine x, what would be dy dx? Cos x. Please don't confuse yourself. And ensure that you get the right information from that toolbox. We say that if you have a sine function, when you differentiate, you get a cos function. But when you integrate, a sine function is when you get a negative cos. So don't mix them up. That differentiation of a sine function is a cos function. So if that was the case, then we'll not be in trouble. But now that is not x. So that's why you have to fix this part. So we let u to be 2x plus 3. And so y will be sine of u. Okay? So what would be the u dx? The u dx will be 2. And then, so remember, the derivative of a constant is 0. So so 3 is not affecting that. Okay? So I have 2. So the dy du cos u. So the final answer, you write dy dx by chain rule is dy du times du dx. So you'll have cos u times 2, and then this will be 2 cos u. So which is what you are saying, 2 cosine of 2x plus 3. So the key thing is that you have to know what are you fixing, and then you'll fix that part to be u, then it will help you to get the u dx. And once you have that one, then you write the formula dy dx is dy du times du dx. Okay? So for substitution method, when it comes to integration, it is more or less the same game. You need to identify which part you are going to fix to make your integral to be a simpler function whose value you can know from the basic elementary integrals. So I'll explain the method in terms using examples. So there's no, I don't give any clear-cut procedure on how to apply the method, but will explain the method using examples. And I know that by the end of the discussion, things will make sense to you. So let's start with the first appetizer. Evaluate integral of 2x plus 3 raised to power 2 dx. This one you can, if you don't know the substitution method, you can still do it and get the answer because it's a very easy thing to expand. So here, method 1, just by power rule, you are going to have 2x plus 3 squared, means this will give us 4x squared plus 6x plus 6x plus 9. Okay? So which will be 4x squared plus 12 plus 9. Okay? So which means then the integral of 2x plus 3 power 2 dx is the same as finding integral of 4x squared plus 12x plus 9. Okay? Yeah. Then by power rule, we'll have 4x power 3 over 3. I hope that one makes sense to you. And this other part will be over 2. So it gives us 6, x squared. and then plus y over 2 y over 2 y 9 over 2 y over 2. It's just 9x, okay? Yeah. Because remember, these are constants. So where there's 9, if you are to force an x, will be x power 0. So when you add 1, so you are just dividing by 1. It remains the same 9, okay? Plus c. Now, method 2, what we are calling substitution method, you will say that this integral 2x plus 3 power 2 dx, you let u to be whole of this bracket. Okay? Then now we want to change the integral from being in terms of x to this new variable u. So by saying this, then it means that the u, the x, the same as if u is 2x plus 3, what is the dx? Two, okay? So, and it's the same thing as someone saying the u alone is the same as? Yes. The u dx is 2. If I say, what is the value of the u? Why are you getting 3? You have this, that the u dx is given by 2. If I don't want to write the u dx, I just want the u alone, what would be the value? Two dx, okay? Which means dx alone is the u over 2, okay? Good. So we are going to have now, this integral now becomes the integral of where this bracket we put 2, we put u because we have fixed it. Where there's the x, we put the u over 2. And I can factor out the half, okay? And then by power rule, what is the value of the integral of u squared? Yes. Power over 3, and then we add a constant of integration, okay? And what is a half times u power 3 over 3? Just 1 over 6. 1 over 6, isn't it? Yeah. Okay. But you don't leave your answer in terms of u. You remember that u was 2x plus 3 squared, power 3. Confirm that this is 1 over 6, not 1 over 2. If you expand that bracket, you should find that the answer is exactly the same as what we have done, what we have got in the other method. but I don't have time to do that. You just check at your own free time. But if you expand this, 2x plus 3 multiplied by itself 3 times, then you divide each term by 1/6. It will simplify to what you have obtained in the first method. And then number 2, integrate 2x plus 4 raised to power 99 dx. You say if you want to be manual, or if you want to be manual, you will not go far. By the time you multiply 2x plus 4 99 times, you'll make errors along the way. And this is not more than 2 marks. Waste a lot of time. So that's why the substitution method comes in handy. So you'll say, you let u to be this bracket, 2x plus 4. Okay? So, which means when I differentiate the left-hand side, I'll get du. Okay? When I differentiate the right-hand side, I get the right-hand side. If you get confused, then just say now, what is du dx? 2. So that's why I was saying that now differentiating left-hand side is du, and then so right-hand side will be 2 dx. So, but if you can get confused, then you can go that long process. Du dx, and then you get it, and then you say du alone is 2 dx. So which means dx alone is du over 2. Yeah. With time, they will make a lot of sense. But now that you're starting, just so we can go along that long process. So which means then the integral 2x plus 4 power 99 dx, we are changing now everything in terms of u. So we'll have the integral of u power 99. Where there's the x, you put du over 2. So we factor out a half, and we have u power 99 du. So by power rule, what is the integral of u power 99? Over 100, okay? Then plus c, okay? And this is nothing but 1 over 200 u power 100 plus c. But remember, you don't leave your answer in terms of u. U is your own creation. So replace the original variable. So 1 over 200 2x plus 4 power plus c. And you'll be trusted now with this problem here. Let's try this and tell me the answer. X plus 2 power 5 dx. Apply the same process to that integral. Is it making sense? What do you get? What's your answer? Okay. You're getting? Mm. Correct. Sanya, are you getting the same answer or you have a different answer? Okay. Yeah, these are very serious team. Correct. So that's the correct answer. 1 over 6, x plus 2 power 6 plus 3. Good. And then the next problem is integral of square root of 2x minus 10 dx. This one I'm doing, and then I give you another one of the same type. So square root means raised power. Square is what means raised power 2. Square is what is raised to power 2. This means raised power half. Okay? So nth root nth root of a number means a number raised to power 1 over n. And then square root of a number means a number raised to power 1 over 2. So just remember that. So which means that this problem is the same as integral of 2x minus 10 minus 10 raised power 5, raised power negative, raised power half, not 5. The above expression is confusing. Raised power half dx. So what is our u? All right. Remember, when you say let u be x, you are actually not doing anything. You still have the same problem. So not also the way you choose your u is also very. You have to be very careful on what you're choosing to be u. So choosing u to be x, you are not doing anything. You'll produce the same integral. Okay. Yeah. So the best thing is to choose u the whole of that bracket to be 2x minus 10. So which means the u is if you get confused, what is the u dx? The u dx is 2. So which means the u alone is 2 dx, which means dx alone yes. So remember, we usually, the objective is that once we have fixed one part to be u, you change the whole integral to be in terms of this new variable. So which means then you will write this as integral of u power a half, where there's the x, you put the u over 2. Then you can factor out a half, u power a half, du. So what is the new power of u after integration? New power of u will be? Is a half. It will be 3/2, okay? 3/2, okay? Yeah, because we are adding 1 to the power, then divide by the new power. We are going to have 3/2, because we'll have a half plus 1, okay? Then divide by the same new power. So when you say u over 3/2, is the same thing as saying? Yes, we use the reciprocal of that fraction, okay? Agnes, are you able to see that? Yeah. So this is the same thing as saying we have a half times 2/3, then times u power 3/2. So that's 2 and 2 cancels out. So 2 and 2 cancels out. So we'll get a third u power 3/2, and then plus c. But you don't stop at that point. You have to remember to put the value in terms of x. So 3/2 plus c. Now, can you try this? The integral of square root of 4x minus 1 dx. What are you getting? Yes? Trust the process. Trust what you're doing. Trust what you're doing and tell me the answer. Okay. Okay, maybe we can do it together. So the first thing is that you realize that this will be written as 4x minus 1 power half dx. Okay? What is your u? Four x minus 1. So which means the u dx is 4. So which means the u alone will be 4 dx. So which means dx alone will be d over 4, correct? So that part is okay. So then now it's just now to rewrite the whole integral in terms of this new variable u. We'll have the integral. The whole bracket is u, so power half. And then dx alone is the u over 4. So we factor out which number? 1 over 4, a quarter. Agnes, I hope that is clear to you. No, so this time round, the 1 over 4 is what is now the fraction here. Then I will have 1 over 4. So what would be the new power of u? Y third? 3 over 2. Yeah, then divide by 3 over 2. Okay? Yeah. And then here, when you say over 3 over 2, the same as times 2 over 3, okay? So the interpretation of this is 1 over 4 times 2 over 3. So 2, 1, 2, 2. So this gives us 1 over 6. So we'll have 1 over 6 u power 3 over 2 plus c. Okay? So therefore, final answer will be and then into raised power 3 over 2 plus c. Okay? Yeah. Then here comes another problem. I don't know which number now. Integral, number 6, okay. Integral of x e power x squared dx. What will be our u? A raised to x squared. Okay, let's see. U is, according to you, J. Agnes, it is x times e raised to x squared. So I want you to tell me what do you think is the best choice for you? What is the value of u? Because we have to fix. E raised to x. X e raised to x. So then now the u dx will be x e raised to x. You are sure? Plus 1. Okay. Which rule are you using? Mm. 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 So okay. So please don't misquote me. Does not mean that now any function that will be involving exponential, if you differentiate it, remain the same. I am going to be misquoted, and I want to redeem myself. Please note, I say if y is e raised to x, dy dx is e raised to x. Remember, if I do something to this x here, or I multiply by a different function here, then it's not the same thing. So it's not the same interpretation. So does not mean that now everywhere, anything that has an e raised to x or has an e, if you differentiate it, remain the same. That's not the case. It can only remain the same if you only see e power x alone as the function. Okay? But also don't complicate your life so much. Don't complicate your life so much. If you are keen enough from the examples we have done, you should know that what you are fixing E or what you are fixing as U should be something easier to differentiate, and then it will help us to to transform the integral into this new variable. Even assuming that you knew how to differentiate this function, what Sanya gave us. So you need to have this as e power x. This will be the correct derivative. But still, this doesn't take you anywhere. You'll be complicating the problem for no reason. Because remember, at the end of the day, once you have this, you need to make dx the sublet, which will be, in this case, du over x e power x plus e power x. And then you have to bring in, because you said that u is x e power x, so then it means that this integral will be u raised to power x, because there's one x that remained here. And then you multiply by du over x e power x plus e power x. This was not the objective of mathematics as a course, to complicate life. It is not the objective of mathematics as a course. In fact, what we are creating is now even a very complicated function than the original one. Are you able to see that? Yeah, so that route will not take us anywhere. It will, in fact, it is making us to be in more trouble than making us reduce the problem. So this is a wrong choice. This is wrong. And remember, we moved away from, we came into the substitution method so that we don't complicate the life on how to interpret simple integrals like this one. What you are, if you are to pick this one as your u, it means that in this problem here, where we are having 2x plus 4 raised to power 99, you want to expand it to multiply 2x plus 4 by itself 99 times before you start to differentiate, before you start to integrate. Will be exactly the same interpretation as if you are to choose this as your u. So that is not the best choice for you. Give me the most appropriate choice for you that is going to make our work easier, not to complicate the problem further. So what we fix to be u is not just anything. You must fix a u that is going to reduce the problem into much easier solvable form. That is the main objective of fixing u. Yes, in the same case, when you are doing the chain rule differentiation, you fix a u that is going to reduce your function so that you can easily differentiate them after introducing this new variable. So what should be my u? And by the way, in this question, I expected you to give me one wrong answer and one correct answer. And this answer is not part of what I expected to get. From if you are keen enough to see what has been happening in the previous examples, there are only two possibilities you could have told me to be u. There are only two possibilities you would have told me that that is what you think is u, and one of them will be right, another one will be wrong, and we'll discuss why one is right and why one is wrong. So there's only two possibilities that for you, what you can actually guess to be your u. But that's not the obvious choice. That's not the obvious choice. Yes. Mm. I'm not sure. That's what I want you to answer. I'm not sure. That's what I want you to tell me. And please remember, what you are choosing to be you should be something that you can differentiate and is going to reduce the problem into very simpler form, into a very simpler integral to evaluate. Hmm? When you say e raised to power x, you see what would be meaning is that, you see when you say x squared, mean x times x. So if you say u is going to be e raised to power x, you mean that the integrand will be x, then u power x dx. Do you want to deal with such kind of stuff? For that to be the interpretation. Okay. If you say u to be, okay, maybe let me reason as to why we are struggling is because we haven't I should have told you this one before we had this class, that please have some rough idea on functions you are doing in Math 121 before you come. So when you check this function, it is a function involving a product of x and an exponential function, okay? So when do you, if you have an exponential function, what is the standard structure of the exponential function? From even the toolbox. We know how to integrate what? We know how to integrate e raised power x or e raised power just one variable, okay? And the problem here, you should be able to see that the problem here is this power here. This power is not in the standard form. Standard form requires that the power of e is just one variable, not a variable squared, okay? So then now, it means that if you fix this power, if you fix that power to one variable, and if there's a way of eliminating this other x, then the integral will be easier to evaluate. If you fix u to be x squared, then du dx is going to give you 2x, which means dx alone will be dx alone. If you make dx the subject. Du over 2x. It's just the same thing you have been doing in the other problems, okay? So which means then you are going to rewrite this integral as the integral of x e raised power u, whereas the x you put the u over 2x. And then you see x and x will cancel out, and then we remain with only u as the variable integration. So this x and this x cancels out, okay? So we'll have, I have integral of e raised power u du. Now these are standard integral. Whose value will be? Yes. Then you replace this by x squared. And this will be the answer. So please note that these problems, as you do them, the choice of u is not just anything that you can pick. Sometimes it's not obvious, like what you have done before. But you should be motivated by the fact that if you meet a function like what we have at this point, there is an exponential function, and the exponential function is a standard integral if the power of e is just one variable. So that should actually inform you on what you are fixing as your u. And by fixing that as one variable, then should be in such a way that by doing that fixation, then all the variables x will be eliminated and your integral will be only in this new variable. And then you carry out the integration. So that would be the best choice for you in that question. Next one, x squared sine x power 3 dx. What would be the choice for you in this question? What do you choose for you? X power 3. What is informing you to make that choice? Sign is standard. That can be one observation. And we expect the sign of just one variable here. Another explanation to why we are fixing that to be u is because, remember, don't forget that what you choose as u will be differentiated at a certain point, okay? What you're choosing as u, that function will be differentiated, so. And when you differentiate x power 3, you are going to get something that involves x power 2, okay? So x power 2 will now cancel this word, this x power 2 that is here, and you'll be safe to have only the integral in terms of the u variable. So what you have said is okay, that we are making that fixation because sign is only standard when this is one variable. So when it's x power 3, then it's not in the standard form. So we fix this part. So let u to be x power 3, which means the u dx is three x power 2. So which means the u alone is the x squared dx. So which means dx alone yeah, so that's what we'll have. And then now you change everything, or you replace everything in the original integral. So we have x squared. We have fixed this to be u. Where there's the x, we put the u over 3x squared. Okay. So at that point, you say u squared and use x squared and x squared cancels out. Is that a question? And so what would be our final answer in terms of u? Third? When you integrate sine, you get sine still. When you integrate sine, you get which function? Negative cos, okay? Yeah, negative cos, and then plus c, but then you remember to replace the original variable. So you have negative a third x cubed plus c. So that would be the answer. Lastly, e raised power 2x plus 4 dx. So the main thing is, what is u? What is u? 2x plus 4, because we have an exponential, and exponential is only standard when there's only variable in the power. So what is du dx? Two. So which means du alone is 2 dx. And what is dx? D over 2. So therefore, this integral will be integral of e power u times du over 2. So I have integral of e power u du. And what do we get? When you integrate e power u du, what do you get? E power u. So when you substitute, you get a half e power. Right. So that will be the answer. So I'm going to give a very long assignment today, either today or tomorrow, on this integration technique by substitution. And ensure that you do it and submit before next week's class. There are a lot of previous lecture videos on the same that can guide you and share the links so that you can freshen up to know how this technique works. But the main thing from all the problems we have discussed, you see that there are problems where what you are going to fix to be u is obvious, but there are problems where you have to be very careful on what you're picking as your u. And what can inform you to know the best choice you are going to make is that you pick a u. This can help you can guide you on what you need to do. You pick a u such that when differentiated, it simplifies. And remember, what simplifies is relative, but then it simplifies the integrand into, okay, I don't know if I'm repeating myself, into a simple form. So the thing is that you'll fix when you meet a problem whereby now it's like you don't have an obvious choice for you. Before you start now saying that now this is what I'm picking as my u, know that what you are picking, if you differentiate it, it can cancel some other excess in the equation to make the integrand simpler, or it will convert the integral into a standard form that you can easily work out the integral. But don't pick a u that is going to complicate your integrand like what we are having here. So this will be a wrong choice. If you go to a choice that is making the integrand even a more complicated problem, then you know that you are not on the right track. So, yeah, good. So I'll stop at that point, and then I'll share some work. I'm sure that you do. If there are problems, let me know. And what is going to help us is to, Asha? I can share the links through WhatsApp. I think WhatsApp would be much easier.